Today I will explain chapter 4 of networking, that is networking device. So first, what are networking devices? Type of networking devices. Example of networking devices: first NIC, then repeater, then hub. Hubs are one of the most important component of network because they act as a central point for all network devices. To connect to the role of hubs in networking, the hub, also known as concentrator, working processor of hub, it is responsible for allowing all systems a central point of connection. When a computer sends a piece of data to another computer, the electrical signal leaves the network card of the sending system and reaches the hub. The hub sends the signal to all ports on the hub so that all systems can check to see whether the data is designed for them. There is a collision indicator on the hub which indicates whether the network currently is having a lot of collision. This could be very useful when troubleshooting network problems. Excessive collision could lead to system dropping of the network. A hub sends a signal to all ports on the hub. Type of hub: first cascading hub, second active hub, third passive hub, and fourth hybrid hub. First cascading hub. If you were to try to chain two hubs together with the switch set to normal, it would be similar to trying to connect two computers together with a straight through cable. It cannot be done because you need to switch the send and receive wires on one end of the cable. Manufacturers of hubs have given us solution that eliminates the need for crossover cables by creating a port on the hub that is already crossover. You simply need to switch the setting to use the fifth port as the cascade port, also known as uplink port. The cascade port connects to a normal port on the next hub. If you wanted to connect three 24-port hubs together, you would need to uplink from port 24 on the first hub to any port on the second hub, then use port 24 on the second hub to uplink to the first port on the third hub. Then passive hubs. The function of passive hub is simply to receive data from one port of the hub and send it out to the other ports. For example, an 8-port hub receives data from port 3 and then resends the data to ports 1, 2, 4, 5, 6, 7 and 8. A passive hub contains no power source or electrical component. There is no regenerating of the signal to ensure that it is readable at the destination. A passive hub simply attaches the ports internally and enables communication to flow through the network. Active hub. An active hub provides the same functionality as a passive hub with an additional feature. Active hubs rebuild the data before sending it to all of the destination ports on the hub. Using active hubs, you can increase the length of your network because although the signal weakens with distance, when the active hub receives the signal, it rebuilds the data, allowing it once more to go greater distance. An active hub has a power source and built-in repeaters to boost the signal. Extra electronics built into an active hub allow for signal regeneration. Hybrid hub. A hybrid hub is a hub that can use many different types of cables in addition to UTP cable. A hybrid hub usually is cabled using thin net or thick net Ethernet along with popular cable types such as twisted pair cabling. A few years ago, hybrid hubs are fairly popular. A bridge is a network connectivity device that is used to break this network down into multiple network segments. A bridge runs at layer 2, the data link layer. It is used to filter traffic by only forwarding traffic to the destination network segment. When workstation A sends data to workstation F, the data will go out the network card of workstation A and will travel the full length of segment 3 in both directions. The signal will reach the bridge and the bridge will look at the destination MAC address of the packet. Once the bridge looks at the destination MAC address, it will compare that MAC address with the MAC address in its bridging table. The bridging table is a table in memory that lists all known MAC addresses and which network segment that MAC address lives on. This table is critical to the bridge filtering feature. Since this is the first piece of data sent on the network, the MAC address for workstation F is not in the bridging table, so the bridge will need to forward the data to both segment 1 and segment 2. It will not forward the information to network segment 3 because that is where the data came from, and if workstation F existed on the network, it would already have the data. When the bridge receives the initial data from workstation A, it records the MAC address of workstation A and the network segment that workstation A receives on in the bridging table. This way, if anyone sends data to workstation A, the bridge will have an entry for workstation A in the bridging table, and the bridge will forward the data only to network segment 3 and not to the other segment. Also note that when workstation F replies to workstation A, the data will need to pass through the bridge, so the bridge will know what network segment workstation F resides on and will record that MAC address in the bridging table. Over time, the bridging table will be filled with MAC addresses and their associated network segments after the bridging table has been constructed. If workstation A sends data to workstation C, the data will reach the bridge and the bridge will forward the data only to network segment. This prevents network segments from the bridge being congested with the traffic. Switch, also known as switching hubs, it has become an increasingly important part of our networking today, because when working with hubs, a hub sends the data to all ports on the hub. If you have a large network structure, this means that if you have a large network structure, this means that you have probably linked a few hubs together, and when data is sent from one system to another, all computers see the traffic. This leads to a lot of network traffic, which eventually slow network performance. The switch acts as a filtering device by associating the MAC address of the system connected to the switch with the port on the switch that the system is connected to. Switch feature. It is a layer 2 device. It works with MAC address. It maintains a MAC address table. It broadcasts when it starts. It maintains all MAC address of its connected device in the MAC address table. It uses layer 2 broadcast address. It has two types as per management. Manageable. It has a console port and setting of this switch can be changed. Unmanageable. It has no console port and it is factory set. three types as per frame checking. Cut through. It will not check the frame before sending to the destination. Fragment free. First 64 bytes of the frame will be checked, stored and forwarded. Entire frame will be checked. Manufacturer Cisco, D-Link, TP-Link, Juniper, Huawei, HP, Mogra, Digicel, Ubiquiti. MAC address learning process. Step 1. When switch starts, it has no entry in the MAC address table, so switch creates a broadcast using FF. Step 2. This broadcast is forwarded to all the interfaces ports. Step 3. The port having device connected replies with the MAC addresses. Step 4. Switch makes an entry in the MAC address table. Step 5. Information switch stored are MAC at connected interface. How it learned the MAC address, static, dynamic and VLAN. Step 6. After populating the MAC addresses table, if any device wants to send information to a particular device, switch checks the source and destination MAC address in the MAC address table and unicast the data. Step 7. After populating the MAC address table, if any device gets connected, switch does not make entry in the MAC address table. When other device will try to communicate with that new device, then another broadcast will be created and the MAC address will be entered into the MAC table. Switch has three functions: address learning, filtering the forward decisions, loop avoiding. Filtering decisions. First, filter decision I will explain. It is a process that switch uses to determine whether the frame will be sent or discarded. It depends on the MAC address table entry. If the destination device MAC address is not present in the MAC table, then switch will store the frame in its buffer memory. Then it will do a broadcast in search of the destination device. If then also it is not found, switch will discard the frame. In switch we can implement policy so that network become more secure and traffic free. Loop avoiding. Loop avoiding I will explain. Sometimes in a switching network loop occurs. Loop occurs when an alternative connection is configured. As for rules, there will be only one connection from one switch to another, but if alternative connection established, data gets duplicated, and the most important thing is that there is no time limit after which the loop will stop. Switch uses spanning tree protocol to avoid the loop. Then router. Router feature are you guys are see. It works in layer 3 of Wayside reference model. It works with IP address. It maintains routing table. It communicates using broadcast multicast unicast routing. It is a process often by a router or other level 3 device. It is a process of choosing the best path to destination and then sending data through it. Cisco, Juniper, D-Link, HP are the companies manufacturer. Here are some companies which are manufacturer router. Router is of two types: wired and wireless. Use the big organization with huge configuration. Wireless use in SOHO, small office, home office. Network wireless router port, WAN, LAN port, WAN, internet port, internet is connected here, LAN port, where networking device can be connected, WAN router ports console. Color sky blue. It is used to configure the router port type RJ45 required cable. Console cable. Console cable, it is a cable used to connect a PC to router, any manageable networking device for configuration. Its one and its RJ45 will be connected to the device, and other end is 9-pin serial called RS232 serial COM DB9. Then Ethernet port, color yellow. It is used to connect LAN to the router, mainly networking switch hub will be connected. Port type RJ45 twisted pair cable will be used type. Ethernet 10 Mbps, fast ethernet 100 Mbps, then gigabit ethernet 1 Gbps. Then serial port, color royal blue, dark blue, used to connect router to router. Port type 1, 60-pin serial port, 226-pin smart serial port. Then auxiliary and aux port, color black, used to connect modem, can be used as console also. Port type RJ45 cable used twisted pair. Here today I will complete networking device.